Good morning, all the students of class 9th. So in this lecture, we will learn about the first chapter of mathematics, that is the rational number and the irrational number. So before we start the lesson, first we will classify number system into two parts. First is the real number and the other is the imaginary number. So what is imaginary number? A number whose square comes negative is called imaginary number. Like here the example for real number. Here the example for real number is under root 25. Whereas the example for imaginary number is under root minus 25. Like in case we have to find the value of minus root 25, then we cannot determine its value. But in case we have to find the value of root 25, we can write 5 here. So the numbers whose value cannot be determined is called imaginary number. Or in other words, we can say that if square of any number comes negative, then it is an imaginary number. Like under root minus 1. Here if we do the square of under root minus 1, we will get minus 1. So since we are getting the square of it negative, so this value is imaginary number. Like under root minus 5. This is also an imaginary number because we cannot determine its value. Here imaginary number can also be defined as the square root of any negative number. We can have many examples like under root minus 7, under root minus 5, and 2 root minus 5, under root minus 4. So these are the examples of imaginary number. Now if we talk about real number, what is real number? The numbers whose square comes positive is called real number. Like under root 4, under root 25, under root 5, under root 7, 2 root 5. So these all are the real numbers because when we do the square of it, we get 4. Here also we will get 25, here we will get 5, here we will get 7. Similarly here we will get 2 root 5. If we do the square of it, then 2 multiplied by 2 multiplied by root 5 multiplied by root 5. So it is 4 multiplied by 5 will give you 20. So 20 is a positive number. Now this real number is further classified into two categories. One is the rational number. Another is the irrational number. Now what is rational number? Any number which can be expressed in the form of P upon Q, where P and Q are co-prime. Now what do you mean by co-prime? Co-prime means they do not have common factor other than 1, like 2 and 3. So here 2 and 3 are co-prime. Similarly 5 and 7, these numbers are also co-prime. So when any number is expressed in the form of P by Q, where P and Q are co-prime and Q must not be equals to 0. Like when we write 2 upon 3. So here 2 and 3, these both are integers and they are co-prime, and here 3 is not equals to 0. So we can say that 2 upon 3 is a rational number. Similarly, 5 upon 2 is also a rational number. Now my question is 2.5 a rational number? Yes, it is a rational number. How? Because we can write 25 upon 10, which can be reduced to 5 upon 2. So here 5 and 2 are co-prime and here 2 is not equal to 0. So we can say that 2.5 is a rational number. Talking about irrational number. So the square roots, cube roots, etc. of natural numbers are irrational numbers if their exact values cannot be obtained. Like when we write under root 2, or we write under root 7, or we write cube root 4. Similarly, we can write square root of 5. So these all are irrational number. Why? Because we cannot determine its exact value. Like when we find the value of root 2, we get 1.414 and it goes on. Similarly, we find the square root of root 3, we get 1.732 and it goes on. So we cannot find the exact value of root 3 as well as root 2 and these all values. So these numbers are called irrational numbers. Now we will talk more about rational number and irrational number. So till now we have studied the classification of real numbers, which is classified into two categories. One is the rational number and the other is the irrational number. So rational numbers are, we have studied that it is represented in the form of P upon Q, where P and Q are co-prime integers and Q is not equals to 0. And irrational numbers are the square root and cube root of those numbers whose exact value cannot be determined. Like when we write square root of 5. So here we cannot determine the exact value of root 5. Similarly, when we write the square root of 2, we cannot determine the exact value of root 2. So these are the irrational number. Now we will talk about the decimal representation of these numbers. So always remember, when rational number is expressed in decimal form, its decimal representation can be terminating or it can be non-terminating but recurring. So if we take the example of terminating decimals, like when we divide 1 upon 8. So here 8 0 times it will be 0, then the remainder will be 1. On putting decimal we will get 0 here. 8 ones are 8, remainder is 2, again 0. 8 twos are 16, remainder is 4, then 0. Then it will be 8 fives are 40. So here we see that 1 upon 8 comes to 0.125. So the value is terminated here. At 5 it is terminated. But when we find 2 upon 3, so when we divide 2 by 3, we write 0, remainder is 2. Putting decimal here, we get 20. 3 6 are 18, remainder is 2. Again decimal is placed, then 3 6 are 18. So this process goes on and there is no termination. So we can say that either the rational numbers are terminating, like 0.125 it is terminated here, or it is non-terminating. But we find that if the values are not terminating, then it is always repeating. Here we can see that here value 6 is repeated. So now taking one more example, if we divide value 3 with 7, we get 0, and the remainder is 3. Putting decimal, we get 0 here, then 7 4s are 28, we get remainder 2, again putting decimal, 7 2s are 14, we get remainder 6, then 7 8s are 56, we are getting remainder 4, then 7 5s are 35, again we are getting remainder 5, then 7 7s are 49, we are getting remainder 1, then 7 1s are 7, again we got the same value 3. So now what will happen when again we will divide, then 7 4s are 28, again the remainder will be 2 and the process are going to be repeated. So here we are getting 0.428571, again we will get 427, we will get 428571, and it goes on and there is no termination. So we can say that it can be terminating decimals as well as non-terminating but recurring. So here we are getting 3 upon 7 is 0.428571, and we always place the symbol bar above the repeating decimals. So these values are going to be repeated. Now there are certain questions, and the question asks like, is 17 upon 50 is terminating or non-terminating? So without dividing we have to give the answer. So what we have to do, we just need to find the LCM of this denominator, it is 50. So write so this 50 can be represented as 2 to the power 1 multiplied by 5 to the power 2. So if we are able to express the denominator only in the form of 2 to the power m multiplied by 5 to the power n, where m and n are whole numbers, then the fraction is terminating. Taking one more example, 7 upon 8. So here also we will take the LCM of denominator, 2 4s are 8, 2 2s are 4, 2 1s are 2. So this 8 can be written as 2 raised to the power 3 multiplied by 5 raised to the power, because 5 is not there, so we can write 5 raised to the power 0. So again we are able to express 8 in the form of 2 to the power m multiplied by 5 to the power n. So we can say that this is also a terminating fraction. Now taking one more example, 23 upon 72 is terminating or not. So again we have to take the LCM of 72. Then 2 9s are 18, 3 3s are 9, 3 1s are 3. So 72 can be written as 2 raised to the power 3 multiplied by 3 raised to the power 2. So the definition was the denominator should be expressible only in the form of 2 to the power m multiplied by 5 to the power n. But here we are getting that 3 is there. So we can say that 23 upon 72 is not terminating. So here are few questions I have provided. So solve these questions before continuing the next lecture.